Hi, I'm Mark Himelstein. I'm the CTO for RISC-V International, and I am so pleased to be here at RT Thread. I'm going to tell you a little bit about RISC-V Everywhere. So buckle up and enjoy the presentation. We're going to talk about the overview, why people use RISC-V, RT Thread and RISC-V and what's going on there, a bit about portability, embedded in real-time support in our ISA extensions and our software ecosystem. RISC-V was founded in 2015. There's in excess of 3,000 members. There's well over 300 companies involved, and we break down the barriers between companies and countries, and we're doing a standard. It's pretty amazing. So we have these messages that we really have been pushing. One is that RISC-V is inevitable. You'll see in the rest of the talk about the success we've been having and where people are using it. We enable the best processors. You're going to see bunches of stuff working on with our RT thread and other things. And then we're building the strongest ecosystem. We're going to talk a little bit about that ecosystem. So tens of billions of cores have already deployed for profit for RISC-V. It's anecdotal. We don't require people report, but based on what people have told us, it's just an amazing amount of product that has gone out already. And I think success begets success. Some people are not in the first wave. They see people be successful. And we're in everything from soldering irons to supercomputers. It's quite astonishing. So first thing is, what are we? Are we open source? Are we an open standard? We are an open standard. You got to think of us very much like you think of Wi-Fi or Bluetooth. We rely heavily on open source upstream projects like RT Thread and other things. We don't do reference implementations. We have partners, and we'll get into that in a little bit. And the only thing that we do as far as might be considered coding is there's a formal model based on technology out of Cambridge called SAIL, and we do the basic architecture test to make sure that people are compatible. So why aren't we like open source? Well, we don't do implementations, and customization is required. It's like the implementation has to be custom. Or you could share with other people, but it's not something we provide. And you can go ahead and extend the instruction set, and that's quite unique. We just saw 2 days ago, Meta put out an inference engine chip, and they said they're based on RISC-V with a lot of customization. We encourage that. We think things that are differentiable and other things, they breed innovation, and we have no restrictions on how the specification can be used. You can take one instruction and use it, and we're okay. The only restrictions we do have is if you want a brand, then you have to pass some compatibility tests. So I get astonished every single day when I wake up and I look at LinkedIn or Twitter and or just even getting news articles with yet another product based on RISC-V. Kathy provided me this list. Look at this list of boards and chips that are being deployed with RT Thread with RISC-V. It's just amazing. And this happens in every single corner of computer science. Again, I know of things like earbuds, walking canes, hearing aids, soldering irons. I mean, wearables, crazy stuff, because people can, because it has the flexibility and we allow them to do that kind of stuff. So again, we're really happy to be here. This is just the tip of the iceberg. And I think you're just going to see considerable growth as time goes on. So why RISC-V? The number one thing is flexibility. You can do what you want with it. There's nobody telling you can't. Other architectures, you either can't customize them at all, or you have to pay enormous amounts of money to go ahead and customize them. We don't require that. The second thing, obviously, is the cost is attractive. I mean, you still have to build the chip, obviously, but there's no licensing cost. And then the next one is the ecosystem. like the reason we're a community at all is because no one can afford in this day and age, I don't care how big you are, to go ahead and do the software ecosystem for a new architecture. We do that as a community. We draft off of each other. We share the effort in not only developing the specs, but in working with GCC or LLVM or RT thread or other things. Our position in history is really great. I mean, Linux, paved that path of, hey, it's our house, Linux is ours, and there's just this pride of ownership that I go through in the last bullet here, and we draft on that. We stand on the shoulders of giants. It's really great to have that in our background, and we foster that relationship with open source software, and we're very grateful for it. And then there's been an EDA renaissance. So, modularity, chiplets, it's easier to plunk down a RISC-V core to go off and do security or IO or something on your chip, even if the main processor on your chip is not yet RISC-V. So Krista, the godfather of RISC-V and the chairman of our board, talks about fragmentation versus diversity, because part of this flexibility, people go like, well, are you sharing? Well, it turns out that when people talk about fragmentation, they're talking about the same thing being done in different ways. In our world, it's really more about diversity. We're using the same product to go ahead and solve different problems, and sometimes we add something custom or differentiable to go ahead and accelerate that. So it's really a different point of view. And to that point, we have a robust economy around systems and software growing, and it is relying on portability. So there's two types of portability we care about. One is applications and runtime software, and that's dependent on profiles and an API like POSIX or libc from Linux or whatever libraries from RT thread. And profiles are very much like a generational group of instructions that work together. I'm going to show you that in a moment, just like other architectures have with versions or generations and so on and so forth. And then operating systems, you got to be able to create one release, be able to download it, and make sure that it can run on multiple implementations. So I talked a little bit about some of this stuff for profiles. I'll also tell you that we group our instructions together into extensions, and the extensions can be chosen, at compile time as to what you're using, and profiles specify that some of those extensions are mandatory, like load and store and add and subtract and stuff like that. There are others that are optional. So the first year Vector was put out, it was considered optional, and the next year it's going to be mandatory. And then there's some non-profile options that don't work together with the particular profile we're talking about, but may work with other profiles. So for example, we're working on a profile for more microcontroller stuff, and it may use a feature we call ZF and X, which is the floating point registers in integer registers. So it takes less footprint space, very attractive to real-time kind of things. And there are major and minor releases. We don't want to drive the ecosystem nuts, but we do need checkpoints. And so the major releases are the things that we send towards our ecosystem. So what are profiles? So the first thing is there's a base in there, and a base is kind of an extension with special properties. It has load, store, jump, branch, add, subtract, logical, really basic stuff. And we have one with 32-bit wide registers and one with 64-bit wide registers. Then we've gone off and we've done a sort of a grandfather or an ongoing profile that just works with the bases, and everything else is optional. And that's good for today, before we have a microcontroller profile for people to brand with RISC-V and have a profile that they can be compatible with. The first profile that came out was in 2019, and we just finally ratified it this year, but it came out in 2019, and that's RVA20, targeted towards rich OS. And in addition to those basic things, it had nice things like multiply and divide, atomics, compressed, etc. And it is a major release, which means that that's something we target towards the tool chains and the OSs. RVA22 came out. It had vector, bit manipulation, scalar crypto, which is really towards embedded in real time, and then FP16, and then hypervisor. In RVA23, we're still defining this, but likely vector crypto, pointer masking, which is used for Java, bfloat16, yet another floating point stuff, more compressed instructions, and the next version of the privileged architecture. So what's coming next is more profile types. So we have A, as you can see here, we have I, B and M are coming. B is basically A with some less things being mandatory, and then M will be targeted towards more bare bones, bare metal, real-time OSs. And matrix operations will be a big thing. It will probably push us into 64-bit instructions. We have more memory protection that's coming out, control flow integrity, things like landing pads and shadow stacks, and then some really big things that will take many years to get through. Cherry out of Cambridge, which is a pervasive security solution for architectures and GPUs. There's both GPUs and the graphics GPUs and so on and so forth. So lots of stuff coming down the line. We're very excited about it. We've built an organization that's scalable, that can go ahead and work on all these things and move the state of the art forward rather quickly. There are a bunch of ISA extensions that are targeted specifically towards embedded in real time. And I'm not going to go through all of these, but I'll point out some really important ones. One is the compressed instructions. We, unlike other RISC architectures, have 16-bit and 32-bit instructions. This harkens back to the days of Seymour Cray. There's plenty of papers out there on how to deal with alignment issues for cache lines or pages, and it is a huge benefit in memory access and in if there is a cache, for cache locality. There's again a number of things here, but the other one I'm going to bring up is scalar crypto. If you did a AES 128 loop with the native instructions, it would take you over 1,000 RISC-V instructions to do one loop. With vector crypto, which is coming next, it will take one instruction, and that will be very competitive with other architectures. But we want to do something in between that wasn't as demanding on logic, but gave us a really good improvement. So we did scalar crypto, and so that's about 75 instructions. So over an order of magnitude improvement over the native instructions. And that's just some of the stuff that we do on a regular basis. Again, I talked about the profile families, B and M, and the bases. So there is this concept of bases I talked about, but RV32E and RV64E have only 16 registers, and that takes up less space as well, and that's very exciting too. So what's coming soon? Big things, vector crypto. We're working on a bunch of extensions needed for Android success. So we're working with Google. They've created a gap list. We're working on refining that. Most of it's being worked on right now, and the question is what will accelerate, what will prioritize. But the idea is, Android, when you go ahead and lock something down, it can be locked down for a good 5-10 years. We want to make sure we have all the things needed for performance and success. And then platform. So we have the profiles ratified. We're still working on the pieces for platforms, and we expect that to be defined in early 2024. But the pieces underneath it, there's a SSE hardware task group. There's a runtime, a platform runtime services, which is basically the firmware interfaces, things like SBIs. There's BRS, which is the boot runtime services, which is how do you get from boot to somewhere where you can, provide stuff to the OS. And then there's a platform security effort as well. So all those pieces will go together in order to create a platform, like other architectures like SBSA or things under Intel that provide platform kind of information. Software ecosystem is our #1 priority, and that's why I'm so excited about being here at RT Thread. but just take a look at really what's going on here. I mean, this is not even current. There's so much stuff on here. It's just amazing. And, we're very excited about this. And I think that, we're working on trying to put, and you'll see in a second, something together where everybody can go ahead and add their icon. But this just gives you an idea. This isn't stuff that's in the future. This is stuff that's here today. And you saw the stuff for RT thread. And I apologize for, oh, it is here, RT thread right in the middle. That's really great. So the icon is here. I'm grateful for that. It'd be silly to be giving a talk and not have the icon for RT thread. So we're very excited about that. And again, up and down the stack, anything you can think of is actually here. So what are the resources that you should think about when you're trying to find out about software on RISC-V? There's a foundational software status for each extension. So this is in our profiles spreadsheet, and you'll see that in a second. I'm going to go through all these. There's a draft spreadsheet for RISC-V status across a bunch of different pieces of software. There's more of a marketing thing for the ecosystem called the landscape, heavily used by CNCF, and we've adopted it. We're very grateful for them. And then we have RISC-V Exchange, where anyone, it doesn't matter if you're a member or not, you can advertise your product if it's RISC-V related. It doesn't matter if it's services or software or IP or chips or single board computers or systems, you're allowed to go ahead and advertise there. And then there's a new project called RISE. It's going to be coming out here in the next month or two that will work on shoring up some of the open source software development for RISC-V. So this is our profile spreadsheet. What you can see is in the lines, there's things like A are atomics, C are the compressed instructions, those 16-bit instructions. And then for each profile, we have a column and says whether it's mandatory or optional. There'll be a flag on GCC. They're working on getting that in, where you can say -M arch RVA 20 U64, something like that. And then all the mandatory extensions will be expanded and included. We also have the status here of when these things are going in and when they're being supported, either as individual items or as the profile itself. But this is a fairly long spreadsheet. There's about 120 extensions so far, and we're working on making sure that everybody can see what's going on. This is the landscape, and I think we may have skipped a slide, so I'm going to go back here. This is our slide on all the commercial and open source software and what the status is. And again, there's links in the presentation, and you can go ahead and follow that. This is the landscape. This is being used again heavily as a marketing tool, just to show all the organizations and all the products that are involved. And then this is the RISC-V Exchange, and here you can see there's a simulator here, and it's got you can click on it and learn how to get a hold of it, and there's links to the website and all those kind of things. And this is free again for anybody who wants to can go ahead and do that. So we've tried to provide a very holistic group of things for folks to get a hold of that that enable them to use RISC-V out of the box, or construct something that's more targeted towards their particular solution. And then verification. So people always ask about verification. DV is done by implementers and DV providers. RISC-V Exchange has a bunch of them in there. The reason this is the case is, again, we don't do implementations. Implementations really vary wildly. But there are also open source implementations that include full RTL and DV. And if we go back here to the big slide here, you'll see on the bottom right, here's 3 of the organizations that are providing full implementations Western Digital provided theirs to Chips Alliance. Low Risk is working with Google and Open Titan. And then the Open Hardware Group is working very heavily with European processor initiatives and SoCs, and they are going ahead and again providing that as open source. So this stuff, on the other hand, you have to really, it has to really be implementation specific, and places like Chips Alliance will go ahead and provide you the DV and the RTL. So this gives you just a basic understanding of kind of what RISC-V is, how it pertains to your world. But I suggest you join RISC-V if you want to know how you can get involved. There's a membership page on the front page of RISC-V International, risc-v.org, and individuals can join for free. There are probably something like, over 50 groups. Half of them are special interest groups that are working on strategy, gap analysis, and prioritization, and the other half are task groups that are really working on specifications, both in the ISA area and non-ISA, things like IOMMUs and things like that. So I encourage you to get involved. If you have a question on how to get involved or where to look for things, we do have an alias, help@riscv.org, HELP@riscv.org. Feel free to send them stuff. And I very much appreciate your time. Enjoy your conference, and thank you for the opportunity to speak to you.